Hi everyone, it's Tracy Reagan. Steve Taylor and I met with Steve Terrana, the creator of the Jenkins Template Engine, earlier today, and I decided to record it so we could all hear what he had to say. Thanks.
Awesome. So I think this picture represents sort of a lot of what you were talking about. I was in a situation where I was tasked with building like a DevSecOps pipeline to support 50 or 60 microservices being built by 5 or 6 different companies. So I work for a federal consulting firm. So we help the government modernize their systems. So there's often multi-vendor software development going on, a lot of adoption of Kubernetes and microservices. And when we showed up, there were 2 700-line Jenkins files, one for Node applications and one for Java applications. And the only difference between them was 10 lines of code about whether or not you should use Maven or NPM to execute unit tests. And as an engineer, copying and pasting a 700-line file and tweaking 10 lines, it felt like there had to be a better way to do this. So the very first thing that started me down this path was like, why don't we just check the repo to see if there's a package.json or a pond.xml, and then dynamically load a library based upon the existence of those files so that we can pull in 2 different libraries that both implement a unit test step. So I can use the same pipeline, but be a little bit more clever about how to pull in the right piece of pipeline code. That sent us down, we wanted to see how far can we take that idea? Can we do that for the entire pipeline? Being able to create tool-agnostic pipeline templates that define business logic, and then separately define what tools are we going to use to implement this templated workflow. So a lot of DevOps tools say they do templating, but what they mean is they do like YAML aggregation and variable substitution, which are not quite the same thing. There's a big difference between having like a parameterized Jenkins file that you pass variables to versus saying like, all right, we want to do a build, test, deploy, but being able to totally swap implementations in a plug and play fashion. So this picture just shows, as you scale linearly, the pain associated with that is exponential. Here's all the challenges. It sounds like we're on the same page. It takes a long time to onboard teams. You end up with this complexity because you're duplicating pipeline definitions and then tweaking those pipeline definitions to support different teams, where you end up with a really brittle, complex pipeline ecosystem, right? A lot of organizations I've seen will take all their pipeline code, put it in a Jenkins shared library, and then in every single Jenkins file, just import that shared library to invoke a single method, because they want to centralize their code, but there's not a good way right now to do it. The challenge with that is like you still have to duplicate the Jenkins file everywhere. In the specific industry that I work, compliance and standardization are a big deal. Giving the developers access to the Jenkins file isn't always okay. There's nothing stopping a developer from bypassing required checks and just deploying to production. So being able to define in one place, this is the tool-agnostic business process that's required by the organization for software delivery, but still being flexible enough to let developers choose the right tools is what we were aiming for. And then the last problem that we've experienced a lot is continuous improvement. Like if you want to update your pipeline, you've got to go open a pull request to every single source code repository, and it gets really hard to manage over time.
So I'm going to stop you. I'm going to stop you right there. I have to ask a question. Have you?
Yeah, sure.
When it comes to microservices, were you thinking in terms of a poly repo instead of a mono repo when you were thinking about building this out? Where was your head in terms of microservices?
My typical opinion is that any independently versionable thing should be its own Git repo. I don't think that's a fact. I know there's a lot of right ways to do things, but just because of the way a lot of pipeline tools work, handling monorepos from your pipeline tooling is very difficult. So I won't be as bold as to say that monorepos are wrong, but I will say that they make life a lot more difficult in a couple different ways.
I am so with you. I was talking to the folks at Google, and apparently they have a big mono repo, and I really want to find out who the right person is to talk to them about what that looks like. Because I feel like the same way, if it's independently deployed, it should have its own workflow and it should have its own repo.
Oh, yeah,
And
at Google. So this is Steve from Deploy Hub, just joined after a little late. So Google's mono repo, I think, is over a petabyte of source code. So it's 1,000 gigabytes.
How do they even, what use is that? I don't understand it, but.
Well, from what Dan Lorick said, their goal is they can tag, they can put a tag or a branch or anything like that into the mono repo, and it goes across everything and freezes everything all at once in one command.
I see. So I think they're treating it kind of monolithic then.
Yeah.
What my response to that, I've had a lot of teams, so I consult. I try to convince teams all the time that multi-repo is going to make life easier. And every now and then someone will come back and say, well, Google does a mono repo. It's got to be okay. And my response is always like, Google has invested millions and millions of dollars into perfecting their software delivery practices. And they're probably not using Jenkins, right? Like they probably have an entire team dedicated to custom CI/CD tooling to make that possible. So just because a mono repo works for Google, I think for the average team doing software delivery, there's still a lot of problems to solve that if you're not Google.
Well, that's why they built Borg, and I believe their build system is Bazel. So, I mean, they build Kubernetes just to deal with it.
Yeah. Yeah.
That's a good point.
Yes, that is a good point, Steve.
So here's the Jenkins Templating Engine in a GIF, and we'll get to code on the next slide. Our realization was that regardless of the tech stack, when you're contextually looking at a team or a set of teams, the business process of the pipeline largely doesn't change. You're going to run some tests. You're going to build an artifact, package and publish that artifact. You're going to hopefully scan it, deploy it somewhere, and then run some more tests. The specifics of what tools implement those steps can vary from team to team. Some teams are going to use like NPM or Maven or Gradle to execute their builds and tests. Some teams might use SonarQube or Fortify. But that business process can remain constant many times. So let's walk through exactly how that's possible with the Jenkins Templating Engine. So on the left and right, super bare bones pipelines, just to demonstrate the point here. We have a pipeline on the left that uses Maven and SonarQube, and a pipeline on the right that uses Gradle and SonarQube. What traditionally would have been two separate Jenkins files, we realized both of these pipelines do a build, and then they do a static code analysis. It would be great if we could pull the Jenkins file out of these repos and define it in one place and say, this is the common template these teams are going to inherit, but they'll get to tell us, are you using Maven or are you using Gradle? And then we'll be able to pull in different libraries based upon the configuration to implement this template. So to do that, you reorganize the code a little bit. You create pipeline libraries in JTE that contribute steps. So in this example, we've got a Maven and a Gradle library that contribute a build step, and a SonarQube library that contributes static code analysis. The pipeline code that lives in these libraries is the exact same pipeline code you would have written in the Jenkins file, just reorganized in a way that we can be a little bit more modular and plug and play. We can define a common templated Jenkins file in one place. In JTE 102, we can talk about that you can have multiple templates. You can create a named template and let teams select which one they want. There's a lot of flexibility in how things can be done. But for the sake of introductions, there's a common pipeline template that defines in tool agnostic terms what the steps of the pipeline are. And then each team gets a configuration file that specifies what tools are going to be used to implement this pipeline. You can define a lot more things than just the libraries in that config file, but we'll get to some of the advanced features later if we're interested in talking through those things. So through this pattern, we don't have to create a Jenkins file in each repo anymore. We can create a common template used by as many teams as you want to, but still give them the flexibility to choose the right tools for the job. These libraries become reusable building blocks to be able to construct your pipelines. There's no reason every DevOps engineer should have to Google SonarQube and Jenkins to find the 15 lines of code it takes to do the static code analysis. We can bundle these steps into libraries and then expose parameters in the configuration file for parameters that you can pass in. So from a framework perspective, in the pipeline configuration, you can pass whatever data you want to a library, and we'll auto-wire a config variable, which gives the steps access to that pipeline configuration. So if you have multiple teams using multiple SonarQube servers, maybe some teams want to be strict and enforce the quality gate and others don't, you can really build these libraries in a way to use the same library across a variety of use cases with different configurations. The last big piece is that...
So go back to that. On the bottom left, we have libraries and the SonarQube and the Scanner 3.0. Where is that kept? Is that kept in each individual team's repository? So that's their data definition. And then the whole pipeline, the Groovy code is kept in a different repo. Is that how it's laid out? Does that make sense?
That's a good question. It makes sense. And the answer is it depends on how you want it to work. So you can create hierarchical pipeline configurations. If you want each team to define their entire pipeline configuration themselves, each repo can have a pipeline config.groovy file that defines everything. In this example, if we wanted to pull out common configurations, that could live in a central source code repository that specifies the common configurations. The aggregation of pipeline configurations follows some rules. So governance is a dial in this framework. You can really tailor how much customization you want each governance tier to be able to customize. So if you work in a highly regulated environment and you want to define sort of the template and most of the pipeline configuration, you can do that. If you want each team to bring their own template and bring their own config, you can do that too. And the way it works in Jenkins is we created a folder property where you configure what's called a governance tier. So on each folder and on the Jenkins instance as a whole, you can point to a pipeline configuration, a set of library sources, and where the templates are. So you can create these governance and configuration hierarchies just based upon how you organize jobs in Jenkins. So if you wanted to not put config files in the application repo, that's fine. You would just define it in a separate repository and then point to it from the folder property in Jenkins. And then depending on how you organize the jobs in Jenkins, you can create whatever configuration hierarchy you need to. So I'm rambling a little bit, but
no, it's all right. I get it. So in your Jenkins UI, I get this from creating the Jenkins file perspective, but from the UI perspective, is let's say each Git repo going to have its own workflow or job, or that's going to reuse the same pipeline configuration, or is there going to be one job that is just, so instead of having
go through the same job?
Yeah. Another way to say it.
Does everybody have it's a separate job? Yeah. So can you push a microservice through the same workflow?
So it ties into the existing way you set up jobs in Jenkins. So you can create multi-branch jobs that say they're using JTE, and you can create GitHub organization jobs that say they're using JTE. So it really works as a separate project recognizer. So instead of saying, go find the Jenkins file in this repo and use it, it says, I'm a JTE job. Let me look at where I live on the Jenkins instance, inherit the pipeline template that's been assigned to me, or choose the one that was defined in the configuration. I think I can pull up a Jenkins instance if that would be helpful.
Sure.
See if I've got my Jenkins container running.
Nice presentation, by the way. Did you do this? Very artistic. It's very nice. Very clean.
Thank you. Thankfully, I've been practicing the same presentation for a while now. So
I get that it gets easier,
but
still, it's hard to get some of these things to make them look nice. It looks great.
Thank you. Let's pull up Jenkins. All right. This is my test Jenkins, so it's going to be a little messy, but it'll demonstrate the point here. All right, so if we look at a single repository, so if you wanted to create the same pipeline template across every single branch and pull request in the job configuration, and this is a regular multi-branch project like you would typically set up, instead of it pulling the Jenkins file from each branch, you say, I'm using JTE. And then if you want to, define a configuration for this repository specifically. Down here, multi-branch projects are just fancy folders. So it inherits the folder property of where do I find the pipeline configuration and templates, like what directory inside this repo should I find the pipeline template we're going to use. When you pull it up a layer, doing it for one repo is not that helpful. Doing it for a ton of repos is helpful. So usually what ends up getting created is a GitHub organization job where you can say, instead of using the pipeline Jenkins file, this entire GitHub organization is going to align to JTE. So then every single repo inside of here can use a common pipeline template. If you've got something a little fancier where some repos in the GitHub org job are going to want one template and another set of repos are going to want another template, you can create named pipeline templates, and in that pipeline configuration file, you can say, I want to use the Git flow template, or I want to use the Kubernetes template, or like however you choose to structure your templates and your libraries is totally up to you, which is honestly why sometimes people can struggle implementing it, because it's very up to you how you want to structure your libraries, how many templates you want to have, how you choose to organize your governance structures. So in the deck, I usually, for DevOps role, I finally showed what templates look like when we write them. So here we have we've got a bunch of libraries that we use ourselves that are on GitHub. And one library that's super helpful for us is our GitHub library that provides an on pull request, on merge, and on commit functionality. So in this pipeline configuration, we can define keywords, which are just variables you define in your config that we're going to inject into your template execution. So we define regular expressions here. You could define these keywords as whatever variable you want to, but for this use case, it's a regular expression. And then that gets used as an input to these on pull request, on merge branches. So we want these templates to be as easy to read as possible. So on a pull request to develop, so this block of code is only going to execute if the Jenkins job is representing a pull request to the development branch of a repository, do a build, do application dependency scanning and static code analysis. When we actually merge to develop, deploy to a dev environment, where dev is an application environment that you can create in your config. So if you have different configurations for each application environment, like a different Kubernetes cluster endpoint or whatever environmental specific context there is, we call these things primitives. So keywords is a primitive, application environments are a primitive, there's things called stages. There's a bunch of stuff you can make in here. So on your application environment primitive, you can define whatever fields you want to, and then we'll inject that dev variable into your pipeline template for you to pass around and do what you need to with. So these libraries, if this was a real pipeline config, they would probably have a bunch of input parameters to them, specifying how we want these libraries to work. So SonarQube contributes a static code analysis step. If a team was using Fortify, instead of changing the entire Jenkins file or template, you would just swap out. I'm using Fortify instead. So the way you choose to organize your pipeline configurations comes down to how much can you abstract out common configurations and what's actually unique about each application that you need to specify in its own pipeline configuration file. So the rest of these slides just sort of walk through each thing that's happening in this file. But libraries contribute these steps. Application environments encapsulate environmental context. And then keywords are a nice way to define variables so that you keep your templates easy to read. a best practice that we have for ourselves is all of these pipeline libraries have documentation. So if someone wants to use our SonarQube library, they can go take a look at, when I load SonarQube, what steps get contributed, and what are all the configuration options that I can pass to this library to make it behave differently. So we've got libraries for all the DevOps things, like Zap for pen testing, loss dependency checker. In each of these libraries, we use a tool called Antora. If we want to talk about documentation as code, that's another thing I like a lot, being able to define the documentation for these repos, for these libraries, alongside the code that contributes them. And then all the docs for JTE explain how library development works. There's a lot of other features we didn't talk about. But I'll stop rambling and see if there's any questions.
Go back to your PowerPoint presentation where you had I wonder if we could, so on under the pipeline configuration, I wonder if can we grab that, Steve, and I guess it's too late by the time, I'm trying to think, let's say we get triggered. Could we, on the fly, generate the proper workflow for a microservice?
You could. What type of data? Are you asking? There's two Steves, so I don't know which one you're.
Oh, I'm sorry, Steve. Deploy hub Steve. So this is what we are.
What are you trying to solve?
We're trying to do, Steve T. Oh wait, you're both Steve T's. That's pretty funny. What I'd love to be able to see is, let me give you a use case that I keep thinking about. We have the ability to start giving microservices risk level factors. Okay, because we're gathering a ton of data about how many, what the impact of a single microservice might be to the entire cluster. We can see if it's failed at deployment, if there's rollbacks, if there's been issues. We can determine that we have a domain structure, a domain-driven design structure, so we can say these are security microservices. They need to go through a more stringent workflow process. So let's just say we had an easy workflow, a medium workflow, and a hard workflow to go through. The hard workflow has more, approval process, more steps. We would love to be able to, on the fly, determine what workflow a microservice goes through.
Okay, and you want to do that sort of post-pipeline exception.
Well, mid-pipeline execution, actually.
No, it would be when the pipeline, when somebody checks in a change to GitHub, at that point, we would query what type of risk level or which path we need to take, and then at that point we would go ahead and make the determination. So it would be, okay. So we would have the information that you guys could query to determine which one to follow.
Yeah, so in this case, we'd have three pipeline configurations,
Yeah.
And we could.
That makes sense.
So you'd have a slow, a medium, and a fast pipeline configurations for the same microservice. And from my understanding, you can do that and configure at the job level which one to execute. So it's just a matter of determining prior to you guys or somewhere in the middle of your stuff, saying we're going to go off and run the slow one versus the fast one, and we can provide you the data to make that determination.
So we're trying to make smarter workflows.
This makes sense. So let me talk through what you can do today, and then talk through what you could do. It's all code. We can do anything. What you can do today is resolve build parameters in the pipeline configuration file. So you could be a little bit more clever where you trigger a job with a certain set of parameters, and then inside this file you can access the env variable. So you could say like env.build type, and figure out which template to use or something like that. And then inside here, if you were to have named templates, for example, you define pipeline template equals, and then you give it a template name. So this could say m.build type if you wanted to define this dynamically from a build parameter. What would be more interesting that you can't do today would be to put a hook into JTE for like dynamic configuration injection, more or less, which is be able to query an external service to get some of this data, which there's no reason you couldn't do that. It's just we haven't needed it so far, so it doesn't exist. But that would be possible.
Well, at least you know what we're thinking about. I mean, these are things that our open source community should be potentially working on. I really do believe, though, that at some point, if we really want to start managing microservices through a pipeline at scale, that we have to be able to control the number of workflows the number of pipelines that we have, right? So we need to template it in some way and to have it highly reusable. And I think you're at a really good point, a really good starting point for Jenkins.
That's one of the value props I talk to clients about. Is like, in my experience, it's a lot easier to manage a set of templates and a set of libraries than it is to manage 700 copied and pasted Jenkins files that you're trying to tweak across each team.
And that's in a monolithic environment. We're not even talking about microservices. I mean, microservices can be more like 7,000.
Yeah.
How do we solve that problem before we get there?
Usually when people get to 7,000, they've invested into like a custom CI system at that point. But yes, I've seen them get into the hundreds.
Even the commercial ones are not giving a good answer for this.
Well, even if you start simple and look at if you have 50 microservices, even 15, if you have 15 microservices and you want to have 3 different versions, one for dev, QA, and prod, that's whatever, 60 or 75, whatever the math ends up being, different combinations of where it could be at any point in time.
Which is why, one of the, not to get too soapboxy, but one of the biggest mistakes I see teams make is that their pipeline, their branching strategy, and their application environments aren't in sync, right? So if you have a certain set of application environments, there's probably a mapping to that in your branching strategy. Like you'll merge to a development branch, which should trigger a deployment to dev. And you'll cut a release branch, which should trigger a deployment to a staging environment or kick off a canary release or something. So these fancy if statements, which is all they are, allow you to create one pipeline template that aligns like how you collaborate in your code base to the different pipeline activities that should take place based upon what happened in the repo. Mm-hmm. So when teams start having like a job to deploy to dev and a different job to deploy to QA, I tell them that's not a pipeline, that's a flute. Like you just want to go click a button to do a deployment. That's not actually building a continuous pipeline that maps to your development practices.
That's just one step in every
purist of me.
That's one step in every pipeline, right?
Yeah.
So a quick question: can you, instead of generating a Jenkins file, can you guys generate a YAML file?
Not right now, because this pipeline template is executed just like a Jenkins file, so it's Groovy. It's just that when this Jenkins file runs, we've added some stuff to it so that it knows about steps and it knows about the configuration. So it's still Groovy right now. I've seen you could build a library that executes YAML, right? Like there's in Jenkins, like you could iterate over a YAML file and just do like a bunch of docker.image.inside calls if you wanted to use Jenkins still.
Well, where I'm getting at is the Tecton project is running into this templating issue. And Tecton is they've built out the CI/CD pipeline, and it's all based on tasks. And they have a library of tasks that you can reuse. But what they're running into a problem with is you end up with a several thousand line YAML file for all the tasks and with all the parameters and what they were looking for. And this came up on the Birds of a Feather yesterday at the CD Con, was wouldn't there be a nice way to have something like Jenkins Groovy libraries to be able to define our language for generating a YAML file. So that's where their heads were thinking, was reaching back into the Jenkins Groovy library, because it's very easy to describe what you want to do without being too wordy.
Yeah, and from my perspective, Jenkins aside, you need three things. You need a set of implementations of steps, right? If you want to do static code analysis, you need a center cube step, a check mark step, whatever. You need something that has steps. You need something that defines in tool agnostic terms your workflow, right? So not getting down to the specific tool level, just getting down to the business logic. And then you need that third artifact, which is the pipeline configuration that says, okay, let's map the steps available to us to the business logic workflow. So people run into problems because they try to put all of that stuff in a single artifact when they're three separate things a lot of the time.
Yep. So for example, that static on the right side panel, you have static code analysis, that function call. What is that? Just a Groovy function call then?
That is just a Groovy function call.
So
it's a step that gets loaded by this library. Yeah.
Okay. So in that static code analysis step, I could actually generate some YAML if I wanted to, instead of writing to a Jenkins file.
This whole template is the Jenkins file that gets executed, but yeah, you can do whatever you want in these steps. Like this is, if you were to run this without loading any libraries, these methods just wouldn't be defined, right? And JT can handle that in a certain way, but this is the Jenkins file. It's just we edit some stuff at compile time so that these steps get implemented dynamically based upon what libraries you've loaded.
Okay, got it. Okay. All right, I'll have to think about this now. All right, it's close. I see what you're doing. Very nice.
Thanks. So I'm always interested to hear like what's missing. So it sounds like the ability to dynamically configure or to dynamically add configuration by like querying an external source would be helpful.
Well, there's two methodologies that we see. Well, one's a short-term methodology and one's a long-term methodology. The short-term methodology is I have a slow, medium, fast pipelines, and I need to choose which one I want to take for a microservice. So that is, and that's where querying external data sources for the decision-making on which one to take comes into play. The other methodology, which doesn't really fit into Jenkins that we see that's going to be coming about, is event-driven CD and CI and CD. So every single step there, a GitHub to a Docker is going to be, instead of being sequential or tied together in a Jenkins file, it'll just be events happening. So if I want to listen for a Docker push, I can have multiple things. Like, for example, a Docker push could, the listeners on a Docker push could be a deployment and then a dependency scan of the container.
Yeah.
So I can, instead of hooking it in sequentially, I would just be looking at listening for certain events for payloads to get passed around. But that's down the road. Nobody's really written a good event-based CI tool yet.
Well, I think
a relay from Puppet
Relay
is starting to go in that direction.
Yeah.
So, but they're at the high level. They're looking at one pipeline calling another pipeline or whatever they're calling them, but not down to really small steps. Go ahead.
my favorite feature about JTE that's not quite event-driven is the ability to do aspect-oriented type stuff. So for example, if I wanted to send an event to Splunk based on the pipeline, I don't want to put my Splunk logic in my SonarQube library because that breaks the plug-and-play side of choose your tools. So you can create steps and annotate them with before step, after step, and then you don't have to specify implicitly to execute this step. It will respond based upon the annotation you've given it. So there's a bunch of hooks here for I want to run some pipeline code at the beginning. I want to run code before and after the step, and then at the end of the pipeline. So it allows you, and then there's like conditional execution. So if you only want to run this step after the build step, and you can access the pipeline config. So here you can be like, only run if the step that's about to run is defined in the pipeline configuration to make this more dynamic. But the idea is that instead of hard coding the relationship for a lot of monitoring tools or Slack notifications or stuff like that, you load a library that implements annotated steps to respond to pipeline events and do things accordingly.
Nice.
If that makes sense.
That's definitely what we're thinking.